I'd like to do a factoring overview. This is lessons 6.2 and 6.3 of the textbook. First, I'll do the main idea and then some methods, common factors, difference of squares, and trinomials. So let's start with the main idea. Now, basically, factoring is the reverse procedure of multiplication. So if you think back to like grade school, you first learned like in third grade, you learned your multiplication facts. You learned things like 3 times 5 equals 15, and things like 4 times 6 equals 24, and so on and so forth. And then a few years later, like maybe fifth grade, then the teacher would give you the problem in reverse. The teacher would say, okay, now what are factors of 15? And so it's like they give you the answer to a multiplication question, and you have to figure out, well, what's the question? So if you can say 15 factors into 3 times 5, or 24 factors into 4 times 6. All right, so we'll be doing the exact same thing, but in algebra. All right, so in algebra, here's how you multiply. You do like FOIL, for example. You might have like, say, x plus 3, x plus 4, and then you multiply. So this is like, I guess, algebra like third grade, but instead of multiplying numbers, you're multiplying binomials together, or expressions of some kind. And so the procedure is FOIL. And so you multiply x times x is x squared, multiply the outside 2, x times 4 is 4x, multiply the inside 2, multiply the last 2, and then combine, if you can, the middle 2 combined, so x squared. 4x and 3x is 7x plus 12. Okay, so that you already know how to do. That's the idea. That's how you multiply two binomials together. Now, when you're factoring, just like in arithmetic, it's like they give you the answer, you got to come up with the question. So same idea. So in factoring, they give you the answer. They give you something like x squared plus 7x plus 12. And then you got to figure out, okay, what two things, if you multiply them together, would give you the answer of x squared plus 7x plus 12. So that's the idea of factoring. Now, there's methods. You don't have to just randomly flail around until you come up with the answer. But this one, x squared plus 7x plus 12, it factors into x plus 3, x plus 4. And how do I know that? Well, because I just multiplied those out right there. But there's techniques. And so let's talk about some of these techniques right now. So the first technique is factoring by common factors. And so let's talk about that first. I'll just say common factors. Okay, so for example, let's say that the question is to factor something like 3w squared. We don't have to use x all the time. Like 3w squared plus, let's say, 6w. Okay, so the idea here is to ask yourself, what two things can you multiply together that would give you 3w squared plus 6w for the answer if you were to multiply those things together? And so the idea of common factors is step one is you look for a factor. In other words, like the 3 and the 6, they both have a factor of a 3 in there. They both have w's in them. So look for a factor that is in common to all the terms. And remember, a term is just like 3w squared is a term and 6w is a term. Okay, so that's step one. And then step two is then you factor it out by doing distribution in reverse. So we can call that maybe reverse distributes the common factor. Okay, so So here we have 3w squared plus 6w. So you say to yourself, okay, both the coefficients have a 3 in common, and they both have a w in common. So the common factor is 3w. And then you make parentheses, and then think of it like an extraction process. I had a 3, I factor it out, it's gone. I had 2 w's being multiplied together. I take out 1 w, so I'm left with a w. And then I've got a plus sign. And then 6w, think of the 6 in your head, think 3 times 2. And so you take the 3 out, you take the w out, you're left with a 2. Okay, so that is the answer. Now, how do I know that's the answer? Because if I multiply 3w times w plus 2, I get the original expression, 3w squared plus 6w. So just to prove it, if you distribute, 3w times w is 3w squared, and then 3w times 2 is 6w. So sure enough, when you multiply back through, you end up with the original statement again. Okay, so that's just one example of the common factors. There's other examples and other videos that show you other examples. This is just a quick overview here. So that's the basic idea of common factors. Okay, next is difference of squares. All right, so this method is just another way of undoing an answer to a multiplication question. So you know from previous lessons, if you have something like, say, x plus 3, x minus 3, you notice the pattern that when you do FOIL on this, you get a negative 3 when you do the O part of FOIL, when you multiply the outside 2. You get a positive 3 when you multiply the inside 2, 3x, and so those cancel. And so as a shortcut, you can just say x squared minus 9. And so the pattern is anytime you have 2 binomials that have the form a plus b, a minus b, the same terms except one has a plus, one has a minus. Anytime you have that form, then the shortcut is you just square the first term. So a times a is a squared, and then you put a minus in between, and then b times b is b squared. All right, so when you learned about this earlier, you could think of this as like a handy shortcut that because you don't have to use the shortcut. You can, of course, you can do it the long way and cancel the 3's out, but it's just a shortcut. You square the first term, square the last term, put a minus between. But now we can, in factoring, you take this process in reverse. And so in factoring, you start with x squared minus 9, and then you break it up into 2 factors, x plus 3, x minus 3. And so let's factor it now. So factor x squared minus 9. So let's pretend for a minute that we don't know that we just did this here. Let's pretend that all we have is x squared minus 9. So the idea is you take the square root of the first term. So the square root of x squared is just x. And then the square root of the second term, the 9, is a 3. So you say x plus 3, and then x minus 3. So in other words, step 1 is you take the square roots of each of the terms, and then step 2 is then you do a plus b, a minus b, where the a is the square root of the first thing, and the b is the square root of the second thing. So it's just using that relationship between a plus b, a minus b. You can take, anytime you have a perfect square minus another perfect square, you can use this method to come up with something times something that gives you the x squared minus 9. Okay, and again, there's more examples in other videos. Like I said, this is just an overview. So now, the third method is trinomials. All right, so how do you factor a trinomial? Okay. So a trinomial, tri means 3, so it means it's a polynomial with 3 terms in it. And so, for example, let's say you have something like x squared plus 7x plus 10. All right. Now, Again, the idea, so we want to factor this. The idea is to think of two things. In this case, they're both binomials, two termed polynomials each. Think of two things that if you multiply them together, you end up with x squared plus 7x plus 10. All right, now there's lots of tricks. In the textbook, they show you like this this box that you can use, and that works out fine. But no matter what method you use, the main idea is this: you want to think to yourself, if you do FOIL on whatever these two binomials are, if you do the f part of FOIL, if you multiply the first two together, you're gonna get x squared right there. And so on this one, there's only one combination, x times x. That's it. All right, and then you say to yourself, okay, if you do the L part of FOIL, if you let's pick another color here. If you multiply the last two terms, whatever those terms are, those have to multiply to a 10. Now here's where it gets tricky. There's more than one possible way to get a 10. You can multiply 5 times 2. You can multiply 10 times 1. You can even do like -5 times -2, because negative times negative is positive. And so because there's more than one combination, sometimes a little trial and error is needed. So you can try like 5 and 2, because 5 times 2 gives you 10. All right, and then put pluses in between here. All right, now we're not done yet, because when you multiply binomials, there's the O and the I. So then when you multiply the outside 2 and the inside 2, those would be x times 2 is 2x, and then x times 5 is 5x. So you need to come up with two numbers that not only multiply to the 10, they have to add to that middle term, add to 7. All right, so let's write that out. So in other words, what two numbers multiply to 10? Well, whatever that last digit is, last term in the expression you're trying to factor. The two numbers have to multiply to that, because that's the L part of FOIL, and at the same time add to that middle number right there. All right, now sometimes it's kind of obvious. The answer just pops out at you. Oh yeah, 5 and 2, because 5 times 2 is 10, 5 plus 2 is 7. But sometimes it can be rather tricky to figure it out. For example, let's say you had something like x squared plus 10x, let's say plus 24. Okay, so when you multiply here, x times x gives you x squared. So that's, by the way, in the textbook, the author's really nice to us. All these polynomials, at least in this chapter, they start with an x squared. There's not like a 5x squared or something. So that helps a lot. You'll get those in the next chapter. But for now, it's always x times x gives you x squared. But so the goal here is what multiplies, so we have some number times some number has to equal 24, and at the same time, that number plus that number has to equal 10. Now in the textbook, they call it P and Q. So P times Q has to equal 24, and P plus Q has to equal 10, but you can call it whatever you want. So there's a whole bunch of factors to 24. There's 1 times 24, that gives you 24, but that doesn't add to 10. You can try 2 times 12, but that gives you 24, but that doesn't add to 10 either. You can do 3 times 8, but that doesn't add up to 10. You can go 4 times 6. Aha, there it is. Okay, so I found out my magic combination. I found two numbers that multiply to 24. So 4 times 6 gives you 24. And then 4 plus 6 gives you 10. So your answer is x plus 4 times x plus 6. Now, how do I know that's really the answer? Well, in all factoring questions, you can always double check your work by just multiplying. So now that we have an answer,